Hi, welcome to Nomis Academy. Hi, welcome to Nomis Academy. This time we'll be dealing with series of geometric progression. Remember what I said series is? Series is addition of the terms in that progression. So the addition of terms in geometric progression. So let's get into it. Series. So we call it sum of geometric progression. So let us consider 4, 8, 16, 32. Remember that sum simply means addition. So if we're asked to find the sum of this geometric progression, just from first term to the fourth term, it would be 4 plus 8 plus 16 plus 32. Now, somebody want to ask, am I supposed to know that this is a geometric progression and not an arithmetic progression? Remember, this one does not follow addition, so it follows multiplication. So when you check the common ratio is checked by second term divided by first term, third term divided by second term. Are you getting it now? Now, if you check with the common difference of arithmetic progression, it will not give you a common difference because 8 minus 4 is 4, but 16 minus 8 is 8. So it's not common. The difference is not common. Then it suggests that it is another type of progression. So you try geometric progression. 8 divided by 4 is 2. 16 divided by 8 is 2. 32 divided by 16 is 2. So that shows common ratio, and that tells that it is geometric progression. So adding it up, 4 plus 8, 12. 12 plus 16 is 28. 28 plus 32 is 60. And that is the sum of this geometric progression. But how do we get to know it if we're asked to find the sum of the geometric progression to the 10th term, or to the 50th term, or to the 100th term? So how am I supposed to do that? So there is a formula for it. So we say the sum of GP. So that's sum of terms of GP is equal to A, open bracket, R raised to the power of n minus 1, close bracket, all over R minus 1. So this is when R is less than 1. When R is less than 1. R is greater than 1. So when R is greater than 1. When R is greater than 1. So this tells the sum of GP when R is greater than 1. But it can be changed otherwise when R is less than 1. So the sum of GP, geometric progression, will be A, open bracket, 1 minus R raised to the power of n, close bracket, all over 1 minus R, when R is less than 1. So when R is less than 1, it's be used like this, such that 1 comes first minus R is the power of n, and then 1 minus R is the denominator. But when R is greater than 1, this formula must be. So for a particular formula to be used, it must be that the R is determined. We should need to find the value of R. And what's R? Remember, common ratio. Let's take an example to see what we are talking about. Example number 1. find the sum of the first seventh terms of 3, 6, 12, 23, 6, 12, 24. So the first thing we're going to do is to find the common ratio. So solution, common ratio. Remember, the common ratio is equals to the second term divided by the first term, which must be equal to the third term divided by the second term. So the common ratio is, the second term is 6 divided by 3, which must be equal to 12 divided by 6, and that is definitely 2, because even 12 divided by 12 divided by 6 is 2, and 24 divided by 12 is still 2. So the common ratio is 2. Now that the ratio, that is R, is greater than 1, what formula of the sum of GP will I use? That is correct. Sn is equal to A, open bracket, Rn minus 1, close bracket, all over R minus 1. So this is when the R is greater than 1. So let us put in our value. Let us put in the value. So the value becomes, our A is now 3. Abi, A is 3. That's the first term. Don't forget the first term. So that will be 3, open bracket. The ratio now is 2. And our n term, that is the seventh term minus 1, close bracket, all over the common ratio, which is 2 minus 1. So what do we have here? We have 3, open bracket, 2 raised to the power of 7 is definitely 2 multiplied by itself in 7 places. So we have 2 times 2, that will be 4, 4 times 2, that will be 8, 8 times 2, that will be 16, 16 times 2, 32, 32 times 2, that will be 64, and 64 times 2, which is the seventh term, that will be 128. So this becomes 128 minus 1, close bracket, all over 2 minus 1 is just 1. So we are left with the numerator. So that will be 3 multiplied by 128 minus 1 is 127. 127. So let's multiply that. 3 times 7 is 21, remainder 2. 3 times 2 is 6 plus 2, that will be 8. And 3 times 1 is just 3. So the sum of the first 7 term of that GP is 381. And that is the answer to that question. So let's take an example for when the R common ratio is less than 1. So let's get an example. Example number 2. Example number 2. Find the sum of the first 4 terms of 1 over 2, 1 over 4, 1 over 8, and so on like that. So let's go into the solution. So the first thing we are going to do when we see sum of geometric progression, because looking at it, you see that it is not addition. So I'll need to find the common ratio. So common ratio is equal to the first term divided by the second term. So the second term divided by the first term. So that will be the second term divided by the first term, which must be equal to the third term divided by the second term. So the common ratio here is, what's the second term now? 1 all over 4 divided by 1 all over 2. So the common ratio becomes what now? 1 all over 4 multiply by 2 over 1. 1 times 2 is 2. 4 times 1 is 4. So I will divide to the lowest term. I will have 1 all over 2. So the common ratio is 1 all over 2. That is applicable to third term divided by second term. So you know this, the third term is 1 over 8. So divide by the second term is 1 over 4. And that becomes what now? 1 over 8 multiplied by 4 over 1. So 1 times 4 is 4, and 1 times 8 is 8. So if you reduce the lowest term, it becomes 1 over 2. So now our common ratio has been established to be 1 over 2, which is less than what now? Which is less than 1. So let us choose the formula to calculate the sum of the what? Of the geometric progression. So since r is equals to 1 over 2, which is less than 1, the sum of the first four sequence is equal to a open bracket 1 minus r raised to the power of n close bracket all over 1 minus r. So you can see this is what we are going to use since r is less than 1. Since r is less than 1. So this becomes our first term. What is our first term? Our first term is 1 over 2. So this will be 1 over 2, open bracket, 1 minus, now our common ratio is 1 all over 2, in bracket now, the n term, that is 4, so close bracket, all over 1 minus, the common ratio is 1 all over 2. So let us begin to calculate this. This can be 1 all over 2, open bracket, 1 minus this 1 all over 2 raised to the power of 4 is just 1 raised to the power of 4 divided by 2 raised to the power of 4. Remember your law of indices. So 1 raised to the power of 4 will still be 1 all over 2 raised to the power of 4 is 2 in 4 places. 2 times 2, 4 times 2, 8 times 2, 16. So this becomes 16. Those brackets all over. Let's simplify these two. So we have 1 minus 1 all over 2, like 1 minus half. So now our answer is definitely half. That is 1 over 2. So that is 1 over 2. So I can simply say 1 over 2 cancel 1 over 2 here. I hope you understood that. So 1 over 2 cancel 1 over 2. So I'm left with 1 minus 1 all over 16. So remember this is 1 all over 1. So in your fraction you find the LCM 16. So to be 16 divided by 1 is 16. 16 times 1 is 16 minus, now 16 divided by 16 is 1. And 1 times 1 is 1. So our answer there is 15 divided by 16. So the sum of the first four terms in the sequence is 15 all over 16, and that is our final answer for that question. I hope you understood everything we did in the video. Take your time to check it again and get the formula installed when r is less than 1 and when r is greater than 1. Bye bye. See you in the next video.